Our next class is propagation characteristics of EM wave. So, whenever we have to consider an EM wave which is propagated through a medium, what type of characteristics which has that will affect the propagation performance of EM wave and the amount of energy transfer with the help of EM wave. So, then here the first property is propagation constant, which is represented with gamma. How to define this propagation constant means the propagation constant of an EM wave is the measure of change in amplitude and phase per unit distance is called its propagation constant. That means here, for example, if we can consider an electromagnetic wave like this is called amplitude. This is called amplitude, peak value. And here the position, these are called phases. These are called phases of electromagnetic wave. So here the measure of change in amplitude and the phase of an electromagnetic wave per unit distance. If we can consider per unit distance, the change in amplitude and phase, that measure is called propagation constant, which is represented with gamma and which can be expressed with gamma is equal to alpha plus j beta because of it is a alternating quantity here, time varying quantity here. That's why which can be represented with a complex form. That's why amplitude means which is real part, phase means which is imaginary part. We will know about these terms here. Amplitude means which is a real part because of magnitude. Phase means it is imaginary part. Right now, that's why which is represented with a complex quantity. That's why propagation constant can also represented with complex form of representation. That is gamma is equal to alpha plus j beta, where alpha is called attenuation constant in a decibel per meter and beta is called phase shift constant in a radian per meter. So generally for electromagnetic wave propagation through free space, there is no change in amplitude and phase. There is no change in amplitude and phase generally. The next characteristic is attenuation constant here, which is represented with alpha here. We are already discussed in the above propagation constant expression, that is gamma is equal to alpha plus j beta, where alpha is called as attenuation constant, which can be defined as the attenuation constant of an electromagnetic wave propagating through a medium per unit distance from the source is known as its attenuation constant. So here the attenuation of electromagnetic wave. What is mean by attenuation of electromagnetic wave here? Attenuation means signal loss. Attenuation means a signal loss, or otherwise the decreasing of amplitude is called as attenuation. The decreasing of amplitude value, the decreasing of magnitude, the decreasing of peak value of electromagnetic wave is called attenuation of electromagnetic wave, which is represented with alpha. Generally, for electromagnetic wave, free space propagation and uniform plane wave, there is no decreasing of amplitude. That's why there is no significant signal loss. Then attenuation constant alpha is equal to 0. The next characteristic is phase shift constant, which is represented with beta, which is also taken from propagation constant. Gamma is equal to alpha plus j beta. So then the phase shift constant beta can be defined as phase shift constant of an EM wave in is defined as the measure of phase shift per unit length or distance. The phase shift constant of an EM wave is defined as the measure of phase shift per unit length or distance. That means here phase shift, what is mean by phase shift here? Phase shift means there is a change of position. There is a change of position is called phase shift here. Compared to the electric field wave, what is the phase shift of magnetic field? Or otherwise compared to the magnetic field wave, what is the phase shift of electric field? That is called as phase shift constant here. For uniform plane wave, there is no phase shift constant. Other waves having phase shift constant. The next characteristic is the wave velocity. Wave velocity means the velocity of a propagation of wave is called wave velocity. The velocity of a propagation of wave here. The velocity of a propagation means the electromagnetic wave velocity. Wave velocity is called wave velocity, which can be expressed as V is equal to omega by beta, where omega is called angular frequency 2 pi f in radian per second. You can note down the units. And beta is phase shift constant, which is in radian per meter. Finally, the wave velocity units are meter per second. So the next characteristic is phase velocity. Phase velocity of an EM wave is the velocity at a point in the wave which is equal to the wave velocity. That means here the velocity of wave at a particular point, if you can consider a point in the EM wave propagation, what is the velocity of wave? Or the velocity of wave at a particular instant of time is called phase velocity. So the phase velocity means at every point the electromagnetic wave velocity is constant. That's why phase velocity is equal to the wave velocity, electromagnetic wave velocity, which can be defined as Vp is equal to omega by beta in meter per second, as same as wave velocity. So the next characteristic is wavelength of the wave, which is represented with lambda. You are already discussed this concept in lower classes, that means BTech first year as well as intermediate second year. Wavelength of the wave, which is represented with lambda. How to define this wavelength? The wavelength of an EM wave is defined as the distance between from one crest to another crest, or from one trough to another trough, which can be expressed as lambda is equal to 2 pi by beta, and which can be measured in meters. How? This definition. What is crest and trough? It is very basic thing. This upper portion is called crest. This lower portion is called trough of wave. This is called crest and this is called trough. If we can consider a wave, the distance between any two neighboring crests or any two neighboring troughs is called wavelength lambda. Is called wavelength lambda, which can be expressed as 2 pi by beta because of, so it is the distance between these two crests or trough is equal to 2 pi, and there is a particular phase is there, phase shift constant is there. That's why wavelength is 2 pi by beta. So the last property or characteristics of EM wave is intrinsic or characteristic impedance, which is represented with eta, which is represented with eta. So here the actually intrinsic impedance means is not a characteristics of EM wave, which is the characteristics of medium. That's why when EM wave propagating through the medium having the property means that property also transfer to the EM wave, because of that EM wave is exist in that medium here. That's why here we will discuss in the characteristics of EM wave. That means how can we define means the intrinsic impedance of a medium can be defined as the ratio of magnitude of electric field to the magnitude of magnetic field H. Magnitude of magnetic field H. That's why which can be expressed as eta is equal to E by H. Eta is equal to E by H, where E is the magnitude of electric field, H is the magnitude of magnetic field. Finally, which can also expressed as square root of mu naught by epsilon naught, where mu naught means absolute permeability of medium, epsilon naught means absolute permittivity of medium. We know the values 8.854 into 10 power minus 12 for epsilon naught, 4.10 power minus 12 for mu naught. If we can simplifying this, 120 into pi is there. Further simplifying 377. The units are ohms here. The units are ohms here. Like this, these are the various characteristics of EM wave when which can propagated in a medium. But in our syllabus, we have to derive all these characteristics. We have to derive the expressions for all these characteristics of EM wave when it is propagated through free space. We have only free space in our syllabus, but in the 3-1 EPTS, electrical power transmission system, there is a concept is there, expressions for the characteristics of EM wave whenever it is propagated through conductor medium, whenever it is propagated through conductor medium. But in the CMF we have only the expressions for alpha, beta, gamma, V naught, VP, lambda and eta for EM wave when it is propagated through free space.